Hello everyone. Today we will look at how to fit models on the prepared data. So we have previously written pipelines, and on those pipelines were used to transform the data. So we have done some imputers, and we have scaled the data and did all those nice stuff, and we already have the data ready. So I have already the data here. For example, as usual, this is the full data, and I have made a copy of the transformed data, which we already, which is the one which we fed into the pipeline, and it is coming from the pipeline, and that's called df transformed dft. And now before we start doing anything, what I'm going to do is we will just fit on a small we'll keep a little bit of data for our predictions, just to evaluation purpose. So for example, I want to df train, so I'm taking all now onwards the subset of this, okay, this or the subset of that. So this is basically few data, and we also need the target labels, right? If you look at the columns, we have our median house value. This is the one we want to predict, and all other things are our labels or the features. So which we have in test, when you fed into the pipeline, we didn't put this guy. All right, so median house value. So I'm gonna that is our target. So I'm gonna also target evaluation, so which is this guy, right? And for up to 5 values. Now rest of that we'll take it for our fitting purpose. For example, df train, for example, that is the rest, and we will use also df train and target train. So this is our so these two are for this is the full, the rest of the data, which is we will use it for the fitting. We'll fit on this and evaluate on these guys. So let us take a simple linear model, like a linear curve. So what we do from scikit-learn dot linear model, linear regression. So we already are already experts for this fitting. We have done quite a lot of things, right? So ideas are same. So linear regression equal to, first of all, create an instance of that, and then I say fit. We don't have to fit transform. We are not transforming. We're just fitting, and we're looking at the values, right? The parameters. So we are fitting on what? On the TFTT and the target train, right? So now we already fitted, so the information is already on this model LR. So now what we are going to do is we see on the evaluation set how this is performing. So we have our evaluation set. So let us take it and see, make some prediction, right? So LR dot predict, right, on the evaluation, right? So this is the predicted value. So now we have the DFT on the evaluation. We have a small so we have also the target values here, right? So we have target, right, these values. So now if you look at the comparison, right, so this is this, and the corresponding value you're getting here. For example, if you take this guy here is almost half, so there's 50% off, which is not really looking really great. Now so we can just, for example, look at the root mean squared error, how the linear regression is performing, but we are going to take our full set. We are taking this guy, okay, and do a error check. So how do we do? So from scikit-learn dot metrics, we import mean squared error. So we'll find the square root of that. So first of all, what we need to do, fit it on the full set, just for fit df train, and we'll supply the full set. And now we'll have make some prediction on the df test, right? This is the predicted value on the full set. And now we have if you look at the target full, right, we have these two guys here. So we will use these two and look at the mean squared error. So I'm going to supply mean squared error, and I'm going to do target full, right, target full, and comma, I'll supply this guy, right, the predicted values, and I'll close that. So I get that one. So we can square root using numpy dot square root and look at the root of that value. So this is this is if you look at this value, and so this is 5 digits here. So the spread is quite a lot, right? So it is not really great, but we have something. And now we'll just look at another model. For example, we can look at, we are going to look at the from scikit-learn dot tree. We'll import the decision tree regressor. So again, the ideas are simple. We'll make an instance, and then we'll just fit, right, dtr dot fit, and again full set with all the features, and then we'll make a prediction on full set, and we have target full value here. Now I can do a mean squared error check, mean squared error, and we are going to do a target full, right, and we'll take this, right, the predicted values. So my god, so what we see is we have all, after all our work, we have all our struggle and tribulations and our hard work, we have finally arrived. We have found salvation. We have found the perfect model, right? Not really. So our guy, our friend, the LinearRegressor, is a really an amazing, wonderful model, but he is actually overfitting it. So if you want to read about that in the video I have here, the Wikipedia. So this, if you look at, see this Wikipedia, so you see this is nice. The nice green curve is like really crazy fitting the data, and this is more understandable to me. I understand this better. So this is a polynomial curve, the blue one, which is fitting everything and there won't be any error. But if you see, look at the linear curve, you can see that it is not that great. It is fitting though, but outside the boundary, the linear curve will perform better, the predictions. We can then compare to, because this is, the blue is like really overfitting. That's why the error is 0. So that's what is happening in our case here. So we need some more another way of, like, you know, looking at evaluating this if how the decision tree is performing versus the performance of a linear regressor. So we'll do that in the next session. So today we have fitted decision tree regressor and a linear regression, and we looked at the errors. And thank you very much for watching.